So let's examine the following conceptual example that deals with mechanical energy of our system. Suppose Alex and Sam are sliding down two different water slides that are of the same height. So Alex is sliding down slide number 1 and Sam is sliding down slide number 2. Both slides have the same height but different pathways, different slopes. We want to find the following two things. A, which person reaches a faster speed at the bottom. So both Sam and Alex begin at initial point up here, a distance h from the bottom, and end at the final point up here, a distance 0 at the bottom. Now we want to find who reaches the bottom faster as well, Sam or Alex. Now we begin by making the assumption that both slides are completely frictionless and there's no air resistance. And that means we can use or apply the conservation of mechanical energy, which basically states that the sum of potential and kinetic energy at the top is equal to the sum of the potential and kinetic energies at the bottom. Now this means or translates to the following formula. Our kinetic energy at the initial point plus potential energy at the initial point is equal to kinetic energy at the final point plus our final point or final potential energy at the bottom. Now notice that we're making the assumption that our mass of both people is exactly the same. But as we'll see in a second, the mass really does not matter. And we'll see why right here. First, notice that the initial kinetic energy of both people, Sam and Alex, is 0. And that's because initially they start with a velocity of 0. Likewise, the final gravitational potential of our objects is 0, of our people is 0. And that's because the height at the bottom is h equals 0. So this guy cancels, this cancels, and this cancels. And we are simply left with our gravitational potential energy at the top is equal to the kinetic energy at the bottom. So now notice that our m's will cancel out, right? So there's an m here and an m here. We cancel them out and we're left with gh equals 1/2 v squared. So h is simply what? Well, h is the change in h because our initial h is 0 and the final h is simply h. So to get our h, we subtract the 2. And we get v equals, well, we bring the 2 over on this side and we take the square root of both sides. We get our velocity is equal to square root of 2 times g times change in h. Or in this case, it's simply h because our initial h is 0. So we see that the final velocity does not depend on the mass. In other words, if the mass of Alex was 100 kilograms and the mass of Sam was 200 kilograms, that means that the bottom velocity would be the same exact velocity for both people because the formula tells us that the velocity is independent of mass. The velocity is given by this formula that depends on the g and the h. And since g and h are the same for both cases, for both Sam and Alex, they begin and end with the same exact velocity. But let's look at part B. Who reaches the bottom faster? Now, Alex converts potential energy to kinetic energy quicker early on. In other words, look, Sam gradually converts the potential energy into kinetic energy, while Alex really quickly converts or exponentially converts his kinetic energy or potential energy to kinetic energy. And what that basically means is that he travels with a faster speed early on. So he will reach the bottom faster. In other words, this means that Alex is traveling with a higher velocity early on and therefore reaches the bottom faster. So let's show you another way of solving this problem. So suppose we have the following two extreme situations. In example number 1, we have a ball that's falling directly downward a distance h, while in number 2, we have an inclined slope with a very small slope. So now our ball falls a distance h, but it falls by sliding via this very long pathway. which object will reach our bottom faster. Now notice, because our h's in both cases is the same, our object will reach the same final velocity. But the question is, which ball will reach the bottom faster? To see this, we have to find what the acceleration of both objects is. Well, object number 1 is in free fall. We're neglecting air resistance or any type of friction, and that means our acceleration going downward is 9.81 meters per second. That means every second our velocity of the object increases by 9.81 meters per second. In other words, after the first second, our mass's velocity is 9.81 meters per second. So after the first second, our object almost completely traveled this distance h, if our h is, say, 10 meters. So let's suppose our h is in fact 10 meters. Let's look at our example number 2, our condition 2. Now, to find the acceleration of our object, we have to multiply by sine of 15. And we get our acceleration, 9.81 times sine of angle 15, and that gives us 2.53 meters per second. So, for object number 2 that has the same exact mass, after 1 second, this guy's velocity is only 2.53 meters per second. Versus in the first example, this guy's velocity after the first second is 9.81 meters per second. That means this distance h will be traveled quicker by object number 1 than object number 2. And you can imagine, the greater this angle, the longer, or the smaller this angle, the longer it takes the object to travel. The greater this angle, the quicker our object travels this distance. And where our angle is 90, as in this case, our object will travel the quickest from this point h high to this point h0.